So this is Advanced Higher Chemistry Unit 2, and this video is all going to be about skeletal formula, which is a new way of representing and drawing structures for Advanced Higher. So when it comes to drawing molecules, you learnt the basics at National 5. So if we take the molecule butane, for example, you would have been able to draw it out as a straight chain with all the hydrogens showing. So each carbon needs 4 bonds, each hydrogen needs 1 bond. Now, if you were to make the model of butane, it wouldn't be a straight line. It's actually a zigzag. So we could represent it more accurately as shown there. And if we want to simplify that, we could take out the carbons and just show the hydrogens coming off each carbon. We can simplify that even further by actually not even showing the hydrogens and assuming that they're there. And that is what takes us to our skeletal representation of butane. And that's what you need to be able to do at Advanced Higher. Now, when it comes to Advanced Higher, you need to be able to draw things in skeletal formula and interpret things from skeletal formula. You won't necessarily get marks wrong for using the National 5 representations if it's not specified, but there will be times where you definitely need to interpret a skeletal formula and you could be asked to draw a skeletal formula. So you do need this skill. So how do we do it? So the first thing you need to know is that carbon atoms are represented as vertices or corners. So essentially, if we want to draw a carbon atom bonded to another carbon atom, all we need to do is draw a line. Each end is a carbon atom. If we make the chain longer, then it's one line. It's one line, then another line. That would be carbon 1, 2, 3. So the lines are the bonds and the ends or the corners are the carbons. Now, hydrogens are not included, but we have to assume that if it's at the end, that carbon needs to have 4 bonds, so there will be 3 hydrogens on it. That carbon in the middle, carbon number 2, has 2 bonds, so we have to assume that there are 2 hydrogens on it. If it is an atom that's not a hydrogen or a carbon, it must be drawn. So for example, an oxygen, a nitrogen, a sulfur needs to be drawn and specified. Whereas these carbons and these hydrogens are only implied. If, however, you have an OH group, a hydroxyl group, or an amine group, an NH2, you do need to show those hydrogens because that's part of the functional group. Same with carboxyl. One particular structure that you definitely need to understand the skeletal formula for is a molecule called benzene. Now, benzene is C6H6. It is a ring structure and it is completely flat. It's planar. It's generally represented by 6 carbons in a hexagonal ring with 3 double bonds alternating between the carbons. However, these double bonds here, 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 and here, 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 they're actually constantly shifting positions. So sometimes you might even see it represented like that. And if you see something like that, it's known firstly as an aromatic compound. And you have to know that each corner is a carbon and that only 1 hydrogen is coming off each one of these. Only 1. This is the only time when you've got a system like this, an aromatic system, where you have to assume only 1 hydrogen coming off of it rather than 2. So the rest of this video is just going to be going through examples, making sure that we can identify the number of carbons, the number of hydrogens. So if you feel confident already, you can stop the video. Otherwise, we'll just continue with some examples. Right, so this first molecule, we need to be able to count the number of carbons. So remember, the end of every line is a carbon atom, and each corner is a carbon atom. So we've got 1, 2, 3, 4, 5. So we've got 5 carbon atoms. Next thing we need to be able to do is do the hydrogens. Well, this carbon has got 1 bond, so we're going to need 3 hydrogens to make it CH3 and then 1. This carbon here is forming 1, 2, 3 bonds, so we're going to have 1 hydrogen here. This carbon here is formed 2 bonds for the double bond, 1 bond on the right hand side, so it's going to have a hydrogen. Carbon number 4 has got 2 bonds, so it's going to need another 2 hydrogens to give it 4 bonds. And carbon number 5 has only got 1 bond, so it's going to need 3 hydrogens. When we add them together, 3, 4, 5, 6, 7, 8, 9, 10, so that's 10. And we also need to be able to name the molecule. So it's got 1, 2, 3, 4, 5 carbons, so it is pent. It has a carbon double bond between carbons number 2 and 3, so it's going to be bute. I don't know why I've said bute again. Pent 2-ene. Pent 2-ene. Our next example. How many carbon atoms? Well, remember, at the end of every line and each corner is a carbon. So 1, 2, 3, 4, 5, 6. And then we've got these ones, 7 and 8. Now here, that is an end of a line, but we've drawn an atom on, which means we're identifying it as not being carbon. So we only have 8 carbon atoms. For our hydrogens, well, 1 at the end, only 1 bond, so 3 hydrogens here. This carbon number 2 has got 3 bonds, so we've got 1 more hydrogen to go on there. Carbon number 3, 3 bonds, so another hydrogen there. Carbon number 4, 3 bonds, so another hydrogen here. Carbon number 5, 2 bonds, so 2 hydrogens. Carbon number 6, 1 bond, so 3 hydrogens. And 7 and 8 both only have 1 bond, so there's 3 hydrogens each. So we've got 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, plus this hydrogen here, so we've got 18 hydrogens. Now naming this molecule, it's got 6 carbons, so it's hex. We have got the OH group, so it is an alcohol, so it's going to end in anol, and that hydroxyl group is on carbon number 3. So it's hex and 3-ol, and then we've got 2 methyl groups, 1 on carbon number 2, 1 on carbon number 4. So 2,4-dimethyl hexan 3-ol. Right, this next one, so how many carbon atoms do we have? 1, 2, 3, 4, 5. 5 carbons. Hydrogens, 1 bond on this carbon, so 3 hydrogens. 2 bonds on this carbon, so 2 more hydrogens. This carbon has 4 bonds already, so no hydrogens needed. 2 bonds on this carbon, so 2 hydrogens. And 1 bond on this carbon, so 3 hydrogens. That gives us a total of 10 hydrogens. Now with this molecule, that group in the middle makes it an ester. So esters always go something yle, something anoate. And if we break it down, we've got 2 carbons coming off the oxygen. So that's going to be ethyl for 2 carbons. And then we've got 3 carbons on the side that's got the carboxyl group on it. So that is propanoate. Ethyl propanoate. Right, this next one, aromatic compounds. You do not need to name aromatic compounds most of the time. With these ones, you're just going to need to be able to identify the number of carbons and the number of hydrogens. So with our carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 carbons. With our hydrogens, so carbon number 1, 3 bonds, so 1 hydrogen. Carbon number 2, 3 bonds, so 1 hydrogen. 3 bonds, 1 hydrogen. Carbon number 4 has 4 bonds, no hydrogens. Carbon number 5, 4 bonds, no hydrogen. Carbon number 6, 3 bonds, hydrogen. Carbon number 7, 4 bonds, no hydrogens. Carbon number 8, 3 bonds, 1 hydrogen. Carbon number 9, 4 bonds, no hydrogens. Carbon number 10, 3 bonds, 1 hydrogen. And then carbon number 11 and 12 have 1 bond, so it is 3 hydrogens each. So that gives us 3, 4, 7, 8, 9, 10, 11, 12. So 12 hydrogens there. Our final one is another aromatic one. In terms of carbon atoms, we have got 1 right at the very end. Remember, that's going to be a CH3 group. We've got 2, 3, 4, 5, 6, 7, 8, 9. So 9 carbons. Then for our hydrogens, 1 bond on this one, so that's going to be 3 hydrogens. We've got a hydrogen here. 2 bonds here, so 2 hydrogens. 3 bonds here, so 1 hydrogen here. 4 bonds, so no hydrogens. We've also got this hydrogen. 3 bonds on carbon number 5, so we're going to have 1 hydrogen. Carbon 6, 4 bonds, so no hydrogens. Remember the OH group hydrogen. Carbon number 7, 4 bonds, but remember the OH hydrogen. Carbon number 8, 3 bonds, so 1 hydrogen. Carbon number 9, 3 bonds, 1 hydrogen. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hydrogens. So that has been using drawing skeletal formula and then being able to count the number of carbons and hydrogens. This is a really important skill to have in in advanced higher, and I hope that you practice and make sure you're able to use this going forward.